This video demonstrates a couple of different ways to manipulate data with RStudio, including calculating scale scores, sorting data, and then subsetting and merging data frames. So I already have open the script for this. So first we need to run the very top chunk to just set up things and do what we need to do. And then we're going to read in a couple of different data sets. So we need to set our working directory, and then we're going to read in a data set called intcon, which is short for interpersonal control. So this is separate items that assessed interpersonal control. And then I split the school days data set into two different data sets so we can look at how to merge those things. So let's go ahead and run this whole chunk. And we get 3 data frames because we asked it to give us the head for each data frame 3 times. So if you click on the first one, that's the intcon, or short for interpersonal control. So we have the subject ID and then the items 1 through 10, and these are all integer values. And then you can see there's some missing data. So NA is the default way to denote missing data in R. And then we can look at the school days 1 data frame. So it starts with subject ID 1 and then has all of the variables we looked at last time. And then school days 2 starts with subject ID 101. So that's just reading in our data. The first thing we're going to learn how to do is to calculate scale scores. So first we need to load the multi-con package. We're going to use a function within this package to do the scoring. So go ahead and run that line by hitting Control-Enter. And if you're doing this at home, you will need to install multi-con before you're able to load it. And now we are going to create a key for scoring. And so you can call this whatever you want, but we're calling it IC for interpersonal control, keys.list. And into that, we create a list where we tell it what we want our outcome variable to be called. So in this case, IC, and is equal to, and then C, and then in parentheses, the items that are going to be used to create the scale score. So we're using items 1 through 9, and then any item with a negative sign in front of it will be reverse scored. So this is a really easy way to calculate scores when you have reverse scored items without having to independently reverse score them. It's one of the main reasons that I use this multi-con package to do scoring. So we create that list, so we can run just that version. We see over here it created that list in the values. And now we want to score the measure and enter the scores in a data set called IC out. So that's what we have right here, IC out. And then automatically rows with less than 80% of the data will be given NA. So instead of giving them a score, they'll actually get basically missing data saying there wasn't enough data to calculate a score. So that's one way that you can deal with missing data. So the function that we use is score test. To tell it the data set you want to use, which is the intcon data set. We use this kind of complicated looking function with the -1 to ignore the first column because that's not part of the measure, it's the subject ID. So if we looked at intcon, that might just help you to get a better idea of what's going on. So the first column, subject ID, and then we have our items in order from 1 to 10. So in order for this key to work, the first column has to be item 1. So that's one reason that we want to ignore that. And then we can get descriptive statistics for the scale scores by using this describe function and then asking it just to do that for the scores variable in this IC out data frame that we are just now going to create. So let's run that piece of the script first, and then run the describe function. And if we scroll down, we'll see these descriptive statistics. And this gives us lots of information about these scale scores. One of the things to notice is that the sample size is 96, whereas the original number of observations was 99. So that means there are 3 people in our sample who had more than 80% missing data, and therefore were not given a score. And then you can see the other descriptive statistics across the row. Now if we look just at IC out, one way we could do that is by highlighting just that piece and using the Control Enter. And then all it has is the list of scores. It doesn't have subject ID or the items anymore. So we can combine those back together so that we kind of need to know who the subject is. We need the subject ID, and perhaps it would be useful to also have the items. So one way that we can do that is we can use the cbind function, and we want to, and where C stands for column, so we're combining columns from the data frames of intcon and ICout, and we're just using the scores variable, which is good because that's the only variable that's there. And in order for this cbind function to work, the columns in your data sets have to line up correctly. And then also both data sets have to have the same number of rows. So let's run this cbind function and then look at the first 6 rows. So we have the subject ID, we have the individual items, click on this arrow to keep going, and now we also have the scale score for interpersonal control. So it did what we wanted it to do. We can also get information about the reliability of the score that we just calculated. We do that by using ICout, so that name that we called our scores when we created it up here, and then the money sign and REL for reliability. And this will work because we use the option up here of reliability equals true. So that information was calculated, but in order to actually see it, you have to ask for it by running this line of script. So go ahead and do that with Control Enter. And then the information are printed here. So the raw alpha, that's the one you should report, so 0.78, it's pretty good. Notice the standardized alpha is a tiny bit smaller, but in terms of reporting to 2 decimals, it would be exactly the same. And then another interesting and useful piece of information that's output with the reliability is the mean for the scale and also the standard deviation for that scale. And then we talked about this in the last lab, but just as a reminder, we can output this file. We probably, every time we want to use this variable, we don't want to have to recalculate the score. So we can output this data that also includes the score with the item. So now that we ran this, in our folder, we should have a file called intcon.scores that includes the item and the score. So we can look in the folder that we are using for the script and the data, and we have this new file called intcon.scores. If we look at that, just what we want, we have the scores here at the end. And here you can see these people that didn't get a score because they had too much missing data. So the next thing we're going to talk about is sorting data. So we're going to start with the simplest case, which is just sorting by a single variable and in increasing order. This is the default for R, so we don't have to tell it anything specific to get that increasing order. So we're creating a new data frame. We're going to call it absent.sorted1 inc for increase. And I use absent here because that's the variable we're going to sort on. And into that, we're going to put something from the school days 1 data set. We need to, the function we're using is order. To tell it again, school days 1, and then the variable we're interested in is absent. So if we run that line and then view the new data set, what we should see is that this is now sorted by absent, starting with 0 and going all the way up to the most number of absences, which is 81. Okay, we can also sort by a single variable, but in decreasing order. So I just changed the INC to DEC to denote we're decreasing now. And the way we do that is within these parentheses, after order, we say that we want decreasing to equal true. So we'll run that and view it. And now you can see we're starting with the highest value and getting lower as we go across participants. It's also possible to sort by more than one variable. So this, we're going to sort by two variables. In this case, we're sorting by learner, and then we're also sorting by absent. And if we look at that, so we've sorted by learner, average comes first because it's going to sort string variables in alphabetical order. And then within each level of learner, it's also sorted by absent. Okay, next we are going to look at subsetting. So if you only want to use part of your data, how do you get a data frame that has only the part that you want? There's actually lots of different ways to do this. The first thing we're going to do is run the names function so we can just look at how our variables line up with the variable numbers. So we'll pull this down so we can see that and our script at the same time. So 1 is SID, subject ID, 2 is race, 3 is gender, 4 is school, 5 is learner, and 6 is absent. So in this first one, we're going to keep the variables 1 through 3. So we're going to keep SID, race, and gender. So we're creating a new data frame. We're going to call it absence1, and into that we're going to put variables 1 through 3 from school days. So the colon means through. So run that, and then just let's look at the names for absence1 to make sure we only have the variables that we want. So sure enough, we have subject ID, race, and gender, so that worked. And then here we're going to keep variables 1 and 6. So now we have to do something a little bit more complicated since our variables aren't right next to each other. So we have to put this C in there, and then we can include a comma in our list of variables that we want to keep. So we want to keep just 1 and 6. So run that, look at the names. So now we have just the subject ID and the variable absent. And here we're going to keep the variables, but this time we're going to list them by name instead of identifying them by their number. So this time we're going to keep SID, race, and absent. And if you look at names, that's what we got. Okay, and then this would be sort of the other way of thinking if we want to just discard variables rather than keeping certain variables. So if you just want to get rid of a single variable, it's easier to tell R to get rid of the one than to keep all of the others, especially if you have a data set with a lot of variables. So to do that, you just put the negative sign in front of the variable number or name that you don't want anymore. So this is going to get rid of the second variable. So when we look at the names for this, now race is gone. Our variable 2 isn't there anymore. And then you can also discard multiple variables, but then you need to use the C with the parentheses. So this time we're going to discard variables 2, 3, and 4. All right, so that's just going to leave us with 1, 5, and 6. And there's another way to subset data frames using the deep Plier package and the filter function. And another thing that this uses is this little symbol. So it's a % sign, a greater than sign, and another % sign, and that is called a pipe operator. So first we have to load the deep Plier package, so if you need to install that first. And the first thing we're going to do is we're going to keep only females in our data set. So we're going to create a new data frame called female, and into that we're going to put information from the school days 1 data set, and then we're going to use the pipe and then the filter function, and this tells R that we want to keep from the school days data set, from the gender variable, only when that is equal to female. And this is something specific to R, that equal, you have to use a double equal sign, and then double quotes around female. So if we run that and then view our new data set, you'll see that we only have female for our gender variable. And what if we want to keep only Aboriginal females? So now we have to filter by 2 variables, and we can do that. So again, we want to have just females, and then we add the ampersand sign because we also want to have only Aboriginal for the race variable. So if we run and view that, Now we still have only females, but we only have Aboriginal females. Okay, next we're going to keep students in levels F0 and F1. So remember there were levels F0 through F3, I think. We only want F0 and F1. We're going to use this symbol, just the straight vertical line, which means OR. So we're going to create a data frame called F0, F1. From the school days data set, we're going to filter so that school equals F0 or school equals F1. If we view that, we can see under school we have only F0s and F1s. Okay, and then the last thing we're going to do is subsetting. Let's say we want to keep students who are absent less than 10 days. So this can be really useful if you want to keep just people who are less than a certain value, greater than a certain value, or between two values. You can do all of those things. So I'm calling this days 10. Originally I wanted to call it 10 days, but R didn't like it when I started with my variable name with a number. So it turned it blue. Blue seemed bad, so I just put the number at the end. Again, we're going to use the school days 1 data set. We're going to filter so that the absent variable within that data set is less than 10. And if we view that, we see absent, all of these values are less than 10. Next, we're going to look at merging data sets. So there's multiple ways you can merge. So one thing you can do is you can bind by rows. So basically this means you just want to add more rows to your data. So if you have different data sets, maybe you had data that were collected in the fall semester that is saved separately from data collected in the spring semester, but it's all on the same variables, you want to put it into the same data set. Or if you're collecting data across multiple sites and you want to combine the data from those sites together. RBind would be an easy way to do that. Something to keep in mind though is that the data frames must have the same variables, but the variables don't have to be in the same order. As long as they have the same variables, this will work. So we're going to create a new data set called schooldays.all, and into that we're going to bind the rows from school days 1 and school days 2. So if we run that, and then let's look at just the end of the data set of school days all. Scroll down. And now we know we have all 154 participants in one data set again, like we had before. Okay, we can also merge the data frames by using the merge function. And this allows us to identify one or more variables that are the same in both data sets and to tell R that that's what we want to merge those data sets by. And the data frames, it's okay if they have differing numbers of rows, but the final data set will only contain the rows that are in common in both data frames. So I'm going to call this one all.merge. We're going to use the merge function, and we want to merge schooldays.all and then the int con. The data are actually about completely different people, but they both have SID starting with 1. So we can merge them even though it's not the same people. Obviously you wouldn't normally want to do that. This is just for demonstration purposes, and we want to merge by this subject ID variable. So run that, and then we can look at the first 6 rows in the data, and here you'll see, so we have, this is the absent data frame, and now it also has our items for the interpersonal control measure plus that scale score, because that was in this intcon data set by the time we got down here. And then we can also look at our last 6 rows, and notice it only goes up to 99 because that was the number of rows that were in the intcon data set. School days went up to 154, but it doesn't go that high because it didn't have something to merge it with from the other data set. Okay, and then this last one is we want to merge, but we want to keep only some variables from at least one of our data sets. So let's say we don't want these items for interpersonal control. We only want to merge the interpersonal control score with the data from the school days data set. So I'm calling this sum.merge, and then we're putting into that the schooldays.all, the whole data set. We haven't specified a specific variable, but from int con, we're only going to put SID and IC for interpersonal control. And you have to remember to keep SID because that's what you're merging by. So if you don't keep that variable, it doesn't know what to merge by and it won't work. So let's run that and then look at the first 6 rows one more time. So here we have everything that was in school days, and then from the other data set we have just the scale scores.